we are spending more time analyzing graphs today. You basically learned everything yesterday, all the vocabulary that is. Increasing, decreasing, constant, that sort of stuff. And we're going to do that again today. But today, yesterday everything was graphical. They gave you the graph. Today, now you have to use your calculator to get the graph. Okay, so you are going to want your calculators out. I am going to show you a bunch of stuff on your calculators. It's absolutely essential that you learn how to use those calculators.
I love dominoes.
You should steal someone's book. All right. Here we go. Interesting. I did say read example 3 on page 56. Somehow I didn't see that at all first period, but there you go. Look at that. You might need to read example 3. I don't know. I can't remember. I wrote this a long time ago. I do want to remind you that you have a test on sections 1.1 to 1.5 on Monday. Monday. All right. Here we go. Example 1. Find the zeros of the function algebraically. Verify graphically. Find the zeros of the function algebraically. Verify graphically. Okay. We have a nice little function here, f of x. And what does it mean when they say find the zeros? What are zeros? X-intercepts. X-intercepts. So how do you find zeros? Plug 0 in for y. So we set y equal to 0, or we using function notation, we would say f of x equals 0. So yeah, we are solving for the x's. So we can do that algebraically. So f of x is going to turn into a 0. So I have 0 equals x squared minus 9x plus 14 over 4x. All right, how do you solve that? Multiply by 4x, very good. Let's relocate that 4x so we can multiply both sides by 4x. Really, that's just cross multiplying, if you think about it. So cross multiply or multiply by 4x. What is 4x times 0?
0.
Big fat 0. Yeah, don't get thrown off by this. And now how do you solve a quadratic? Factor. X times x is x squared. What times what is positive 14?
Negative 7 times -2.
Negative 7 and negative 2. Very good.
Thank you.
Which means x equals what? X equals 7 and x equals 2. So these are the x values when the y is 0, which means I can write them as ordered pairs 7, 0, and 2, 0. Is this something that we can check?
Yes.
Yeah, absolutely. So to check. Now, I am giving you to verify graphically. This is the key in this class right here. Verify graphically. When you have a test, it's your job. During the practice, during class practice every day. That's where we do all the math, right? You do it algebraically, you do it graphically, you do it left and right and upside down and backwards. Okay? But on a test, I don't care which way you do it. So if you can do this entirely on your calculator, fine. I don't care. It's a perfectly valid method. You can do it algebraically like this, fantastic. But your job is to verify. Make sure you get it right. I don't care about anything else except that you get it right. So to verify graphically, I'm going to graph this because when in doubt,
Graph it out.
now, the hardest part about graphing something like this is getting it plugged into your calculator correctly. Now, when it's written in this form, this giant division is performing grouping. It's saying that there's grouping symbols on top, and we're dividing by this whole thing. So you need to tell your calculator that, and you need to make sure that you type it in correctly. So for most of us, you have to type it in using parentheses, otherwise it's not going to graph properly. So typing in x squared minus 9x plus 14 divided by the 4x. And you can graph that. All right, so you can do, a zoom standard. If you want, x squared minus 9x, I'm using multiple graphing utilities here. Okay. I think I need on my Casio, I'm gonna go to V window. I don't know what the V stands for, but V window's right there. It's a second function on the Casio, and STD would be not what we're doing in this class. Okay, enough. Okay, that really stands for standard window. All right, I'm gonna do a zoom standard. All right. I don't know whoever said math wasn't fun.
Yeah, there's
So much fun, right?
controversial statement right there.
All right. Zoom standard. So standard sets the window to a -10 to +10 window, and then I can go back. I can press exit and then draw, and we have a nice -10 to +10 window. So this is -10 to +10 on the X and -10 to +10 on the Y. Whenever you're graphing on your calculator, you just need to make a little sketch of what you're seeing, and it doesn't have to be gorgeous. It just has to be there. And so I make a little sketch like that. And how are we going to verify if our x-intercepts are correct? Trace. Trace is a great way to do that.
Plug in the number.
Yeah, so we can use trace, and we're going to plug in a 7 and label our graph. So I see that I have 7, 0, and the same is true. Oh, wait.
Sorry, you just don't like my vibes.
Exit. Option. No. Exit. How do you? Oh my God.
Wait, it touches 2 and 7.
Yeah. Sorry. Casio people, I'm having a brain fart. How do you do trace on the Casio?
All control deletes.
Oh, there you go. Okay. First, I don't know what. Thanks for that. All right. And then, of course, we can also check the 2 as well, and we see that there's another point there at 2, 0. Okay. Now, that's not the only way. So I love doing things this way because it forces you to have to know the algebra in order to check your solution. Okay? But guess what? Your calculator is smarter than that too. You don't have to know the answer to check it. Your calculator can calculate the answers for you. The Casio is super easy. The TI is not so smart. both calculators have a calculate menu. And so on the TI, you see the calculate menu is above trace. It's a second function, so you're going to do second calculate. And on the Casio, you have gsolve, which is graphing solve. So you're going to do a shift and then gsolve. And you can see they have the same kind of menus, pretty close anyway. Zeros, hey, zeros. That's what we're trying to find, isn't it? On the Casio, zeros and roots are the same thing. So root is the old word. And so on the Casio, all you have to do is press root, and it gives you the root. And then if you want the other root, you just arrow to the right, and it gives you the next root. You don't have to know anything. It's pretty fabulous. Now, on the TI, it's not so handy. We're going to select zeros. So number 2. And in the TI, it has this whole crazy menu that you have to go through. In order to figure this out, what we're going to do is says left bound. So we're going to put Tinkerbell right on where we think the 0 is. And our TI is telling us to go to the left. So I'm going to do left, left, left. And there's Tinkerbell and hit enter. So we do left a little bit, and you can see it pops up an arrow on the screen. And now it's asking us to go to the right. So we're creating these left and right boundaries. So I'm going to go right, 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 right. We're going to go right on past that 0 using only the left and right arrow keys. And you can see when I hit enter, we get 2 little arrows. And what that's doing is it's telling the calculator to find the 0 value between these 2 little x values. So we're looking for the boundary for it. And then the last thing is guess. And so you're going to move Tinkerbell back to where the 0 is and hit enter.
Why are we moving Tinkerbell?
If you want to use the 0 menu to actually solve it, you have to do that operation. So on most of the TI menus, you have to do the whole go left of it, hit enter, go right of it and hit enter, and then back to it and hit enter. Okay, come on.
Come on, Nicholas.
All right. Go left a bit, hit enter, go right past it a little bit and hit enter, and then go back to it and hit enter. It can be really, really useful. You'll know you did it right if it actually says 0. If it didn't say 0, you didn't do it correctly. Okay? We'll try it again in a little bit with another menu. So let's try something else. Example 2.
Whoa.
Use a graphing utility to graph the function. Determine the intervals over which the function is increasing, decreasing, or constant. That's fine. You can say just like graph with calc. Yeah, you can summarize what it's. And the intervals over which the function is increasing, decreasing, or constant. What you need to remember about intervals. What variable are we interested in when they ask about intervals? The x variable. We're interested in the x-axis because the x-axis, the x variable, is our independent variable. Everything about the function depends on those x values. So that's all we care about. So we're going to go ahead and use our calculators to sketch the graph. So once again, go back and type in your functions. We're using our calculator for the graph. Right? All right, here we go. So I've typed in my functions. I hope you have too, because you're going to want to follow along on your calculators. All right. So now I'm going to go ahead and just draw and graph my functions. And they look pretty similar. Do we have good graphs?
Yeah.
Really? No. So what's missing? The bottom here is being cut off, so we don't have a very good window. So there's a couple of options that you can do. I'm going to show you how to change your window because I like, it's important that you learn how to change the window and understand what's happening. Right now, both of my calculators have a standard window from -10 to +10 in the X and -10 to +10 in the Y. So right now, what we're missing is this little value here, the little bottom of this graph right here that's cut off, okay? So what we need to do is we really need to take our Y-axis and make it lower. So on the TI, you can just go to Window. And on the Casio, we want the V window, so we're going to go back and do Shift V window. And you can see, oh, viewing window, that's what that stands for. Okay, the viewing window. And we want to go down to the Y minimum value. The Y minimum value right now is at -10. What do you want to change it to?
Say -15.
Negative, let's try -20. Actually, I'm going to do -22. I have more knowledge now. Let's do that. Okay. But yeah, you can, it's a really a guess and check kind of game. And you can try that. So you just have that Y minimum to -20 or 22, somewhere around there, 25, something like that. Now, the reason that I'm showing you how to change the window is because zoom out is not the best. It doesn't usually work right, all right? It doesn't show you the important things of the graph. The Casio actually has a better auto graph, but it's not fantastic. So once you changed that, then I'm going to do on the Casio exit and graph, and on the TI you just have to press graph. So now we can see the bottom of that little curve there, which would also be known as a minimum. Technically those are called, that'd be a relative minimum, and over here we have a relative maximum. How come I want to talk about why we call it a relative max or a relative min. Would this be the overall maximum on this graph?
No.
No, it's not. The maximum goes on to positive infinity. So we use the word relative because in a relatively small little space, this would be a maximum. All right, for a relatively small amount of X values, okay? So we use those words. Now, I'm gonna go ahead and we're gonna sketch these little graphs here. Make a sketch. And again, it doesn't have to be beautiful. It just has to be there. Look how fast I did that. And it's fine. That's all I need. Okay? In order to figure out where our function is increasing, decreasing, or constant, what information do I need to know? The relative minimum and the relative max. So I can see that my function is increasing here, and it's increasing here, and it's decreasing in the middle. And we did that yesterday. V-A-S-I-G. Okay. In order to actually describe the intervals, I really need to know what this maximum, a relative maximum is, and what this relative minimum is. How are we going to do that? You're going, well, you could use trace, but it's not very specific usually. use the calculate menus. Yes. Okay, both of our calculators have a calculate menu. So on the TI, second calc, go to your calculate menu. On the Casio, shift G solve, graphing solve. Go to your menus. And what do we want to find?
We missed it.
Second calc. We want to go find either the minimum or maximum. I'm going to do the maximum first. So on the Casio, super easy. One button and you're done. On the TI, not so easy. So I'm going to push number 4 for maximum. And again, it's going to take you through the menu of go to the left, go to the right, go back. Okay? So here on my TI, it says go to the left boundary. So I'm going to take Tinkerbell and just moving left and right. I'm going up to the maximum, but I'm going to go left a little bit and hit enter. That you see it pops up a little arrow. Now it's saying go to the right. So we go to the right of the maximum a little bit and hit enter. And the guess, go back to where you think the maximum is and hit enter. Left enter, right enter, guess enter. Okay? 3-step process, kind of irritating. You'll know you did it right because it says the word maximum. If it doesn't say maximum, you did it wrong. Okay? Yeah, so you didn't quite do it right. -1.7 for the maximum. So ladies and gentlemen, do it again, please. Go back to your calculate menu and find the minimum. You know, if you have trouble, I'm going to help you now. Find the minimum, ladies and gentlemen.
Okay. Now that is.
Find the minimum.
Oh, that's How do you see the
Once I got past that.
Are you doing the maximum or the minimum? Okay, so there's your maximum there. Let's do minimum. Alright, so here's my minimum. Here's my minimum. Yeah, a little bit left, a little bit. Good, and now it says straight down, so go right. Right. There you go. And now guess. Go back to the minimum. All right, ladies and gentlemen, what was the minimum? All right, what was the minimum? 2 negative. What was it? -20. Yeah, I got -2. All right. I'll be there in a minute. All right. Here we go. Now that we have the maximum and minimum values, now we can actually write our intervals. What's the increasing interval? For what x values is our function increasing? Yes, -infinity to -1. All of those x values, -infinity to -1. It's increasing. Where's the other interval? Yes, 2. All the way to positive infinity. Remember, when we're doing intervals, all we care about are those x values, not the y values, the x values. So everything to the left of -1 and everything to the right of +2. What x values are we decreasing?
-1 to 2.
-1 to 2, and you'll notice they're both open intervals, parentheses, no brackets here. All right. Questions on those? Okay. If you need help with the maximum, you can ask me during you guys are working. All right. Round up here. All right. Example 3. Graph the function. Determine the intervals for which f of x is greater than or equal to 0. Lots of graphing work today, all with your calculator. If you do not have a graphing calculator, then I suggest you go and get one from the finance office. I just went yesterday, they still have over 40 calculators that they could lend out. I know. They're supposed to be open before school, at lunchtime, and after school. Okay, here we go. So this is kind of interesting. I enjoy these kinds of questions where we want to know where our function is greater than or equal to 0, which is kind of a different thing. But we can start by asking ourselves, when in doubt, graph it out. So I'm going to go and graph this function. What shape should it be? A V, absolute value V. Yeah, okay, good. 4 minus absolute value in your calculators. For the TI, it's under the math menu. So we're going to go math, arrow over to num, math, num, ABS. Not anti-lock braking system. Absolute value. On the TI, I'm going to do 0.5, and then 4 minus absolute value. If you just press option and num, then you have ABS. Option, num, ABS on the Casio. So absolute value of X. And then I'm going to go ahead and just graph both of those. Oh, exit. What happened? Oh, there's an EO. Typed that wrong. 0.5. 4 minus option, num, ABS. Absolute value of X. Okay. Okay. My windows are still set to the other window size, but that's okay. I could go back to the standard window, but I'm not going to approach the STD figure. Okay. So I'm going to make a sketch. And my sketch is something like this. Real simple V graph here. Okay. So to answer this question, we're trying to figure out where is our function greater than or equal to 0. Remember, f of x is just fancy lingo for y. So they want to know where are the y values greater than or equal to 0. Can I figure out where they're equal to 0?
Of course. Yes.
All right. Sure, we can figure out where it's equal to 0. Can you look at the graph and just guess? Yeah, what do you think it is on the graph? -4 and +4. So we're thinking at -4, 0, we've got a 0, and +4, 0. And how would you verify your guess? Trace would definitely be the easy thing to do. So I'm going to hit trace and type in the -4, and trace and type in a +4. And sure enough, those are definitely the zeros. So I can figure out where my function is equal to 0. And if I know that, can I figure out where my y values are greater than 0?
Yeah.
Where are the y values greater than 0?
Greater than between those two.
Yeah, everything above the x-axis. All of these y values are greater than 0. Anything above the x-axis is where our function is positive. So for what interval does that happen? -4 to 4. Brackets or parentheses? Brackets.